Welcome back to Think Design Work Smart. I'm Alex Bolboaca and I'm coming at you from the Mozaic Works studios. And what I have for you today is yet another conversation with interesting people from software development. This time, my guest is Jan Russell. He is the reason I am very interested in having this chat with him is both because he has a very long experience, almost 30 years in software development, and because he's very passionate about F# and functional programming. But I'm sure we'll talk about much more than this. So welcome, Jan.
Hi, Alex. Thank you for having me on your chat.
Before we start, I'd like to go a little bit into your biography. And my favorite question is, how did you end up in software development? What made you take this path?
Oh, it's a long story. So I first met computers back in 1982. So the BBC B had just come out, and my school got two BBC B microcomputers with the 5.25 inch floppy disks, the big floppy ones. And I got a chance to play with those, so I learnt BASIC, and then didn't really touch a computer then for many years, 10 years at least. And then I went to university to train to be a teacher of mathematics. And as part of that, I had to use a computer for various things. And I actually realised in my last year that I preferred computers to children. So I decided to move into software development rather than teaching. So obviously I did things like VBA in Excel and Access Basic as well. So I was quite good on both of those, and coming from a mathematics background, that was quite good. So I got into software development that way. So I started doing Office development like that, and then gradually I taught myself SQL. I taught myself how to program in proper VB, as it was at the time, and then went from there. So I started in 95, so yes, nearly 30 years. It's quite a long time. So I did VB6, I did some Delphi, I did some various other bits and pieces as well, and then picked up C# in 2003, and it's been .NET since then. And I started to learn F# in 2010 when F# came as part of the delivery for Visual Studio. So when you installed Visual Studio, you got C# and you got F# as part of the same thing. I started to learn it at that point. But I said the learning materials weren't particularly good. Things have moved massively on since then. It's a great time to learn F# now. You know, there are plenty of good books, mine included, but plenty of learning materials online as well. Lots of people blogging about F# now as well. So it's a good thing to do.
Yeah, and I remember that we met at Socrates UK, and your.
Can you remember which year it was? Did we meet on one of the World Cup football years? So was it something like 2014 or 20? I can't remember. It certainly was a few years ago anyway.
Yeah, it was a few years ago. I've been away from conferences for a few years. So
same here, yeah.
Doing more of remote stuff and videos and things like that. But what I remember is that you are very happy with F#. I think you said something like ever since you learned F#, you are the happiest and the most productive ever.
Yep.
And I like to get into that a little bit. But before we go there, I looked on LinkedIn on your biography, and you're also mentioning domain-driven design, extreme programming. So let's start with extreme programming first. When did you first get in touch with extreme programming practices like refactoring, pair programming, test-driven development?
So I read the book, I think, in 2003 or 2004, the first Extreme Programming Explained book. Actually, I read the second edition, so it might have been 2004. Yeah, I think it might have been. And then I went back to the first edition and read that as well, because the second edition obviously was slightly different than the first. The first was in some ways slightly more extreme. It was just very different than what I was doing previously. So what I really liked about it was it put good developer practices at the heart of software development rather than process. So unfortunately, I've come across a lot of Scrum. Not a great fan of Scrum for a number of reasons, but it's generally badly implemented rather than it being a generic problem with Scrum. It's generally just that it's done as a process-driven thing rather than thinking about writing better software or delivering better software. So I liked XP from that perspective. So things like shared code ownership, and that made a lot of sense to me. Even the general principles behind it, as well as things like safety and communication, that all made a lot of sense to me. So yeah, I got into XP at that point. So I learned how to pair program. Pair programming at the time wasn't such a good thing for a number of reasons. Now software developers they're just like normal people now, and particularly senior developers. But back in the early 2000s, not all senior developers were human in many ways. So a lot of them didn't tend to have good body hygiene, amongst other things. It wasn't a pleasant experience pairing with some people, but things have changed. It's a very different experience now.
Yeah, I think so. When did you start doing test-driven development? And actually, I'm more interested in how hard did you find doing test-driven development?
I found it quite hard, to be honest. It was... I went down lots of very bad paths. I read lots of... I didn't read the book that I should have read, which was Kent Beck's book. And I read another book instead, and that book led me down a different direction, tending to do tests that I shouldn't have written. And I tended to start making a lot of use of mocking, a lot of use of actually testing the internals of functions rather than testing behavior. So it took me a while to catch on to the fact that this was a lot harder than it should have been. And eventually I went to a conference. I just happened to be talking to somebody, and they said, well, they didn't quite say, well, you're doing it wrongly, but that's basically what they said. And then it was sat down and explained, what test-driven development really was about testing behavior. And suddenly light bulbs went off, and it sort of made sense at that point. And, trying to push that sort of idea as much as possible.
Right.
But it was definitely hard. I can't say I've had I can't say everything's clicked straight away all the time through my career. I've made some very, very bad mistakes over time. But a lot of that is not having good mentors. Some people are very lucky that they've got, they latch onto somebody very early in their career and they learn good habits. I didn't have that.
Yeah, I've been telling this story. I was lucky to have a mentor. I was doing C++ back then. It was 2002, I think, 2003. And basically, there was no unit testing framework for C++ at that point.
Yeah.
So we wrote our own, but it was mandatory to write unit tests, and we would write unit tests and review the unit test, and they were part of our design process. They have to be there. We didn't do test-driven development or test first, but kind of a design process that included tests and that included review afterwards. And while it wasn't the most productive way of writing software, but it set up for me very good habits. It was very easy for me afterwards to start writing tests. It wasn't...
Yeah, well, it's not, in some ways, it's not the tests that are important, it's the thinking about the tests, because they're the first users of your code. So if your tests are difficult to write, that's a sign that you're not writing code that will be easy to work with. So it's good feedback from that perspective. The tests are, I won't say they're a byproduct or a waste product. They're not. They're obviously very important. but it's the spending time actually thinking about the problem you're trying to solve and how to make your code as nice to use as possible. That's the important part.
Yeah, and I think I was very lucky because we were very careful with these things, and I think that's when I learned how to write testable code and how to think about tests first.
Yeah, I mean, C++ is obviously a very different language than C# or Java. It's much easier to make mistakes in C++ than it is in C# and Java. Your hands are held quite nicely in these languages. So, but make a mistake in C++ and it can stop your machine.
Yeah, and it used to be even worse. Nowadays, you can write C++ code that almost looks like C# or Java.
Really?
Yeah.
Okay.
So if you can easily forget about pointers and all those weird stuff because you have classes that encapsulate or data structure that allow you to use kind of smart pointers, which are almost like garbage collected things. So it's much easier now, but back then, yeah, it was very difficult to write C++ code.
Yeah, I never looked at C++. I went straight onto the easy languages, and I've stayed there. I moved on to an easier language over time. You know, I find F# much easier to reason about than C#, for instance.
And to be honest, I also switched to other languages because C++ is kind of the everything language. So you can write in any style you want. You can write procedural, you can write object-oriented, you can write, I think, even event-driven nowadays. Definitely functional nowadays. So you can do a lot of different stuff. But because of this, it's very, very complex. So nobody actually uses C++. What they use is a subset of C++ that matches their projects or their guidelines. But yeah, I also switched to C# then and later to Java and later to other languages. So that's kind of where we are. So domain-driven design, that's another thing that I think is interesting.
Yeah.
I've seen some of your articles on using F# for domain modeling, which I find very interesting, and it looks very nice. Actually, it's incredible how easy
it is.
Yeah,
not perfect. It's not. It's not like Haskell. Haskell's another level. Well, it's another few levels on. You know, the Haskell type system is really powerful. So you can get, when you compile a Haskell program, basically you're checking correctness of the program. You know, it's very hard to write invalid code in Haskell once it compiles, but it's getting it to the compiled state that's difficult. F# takes a slightly less strict view of the world, but yes, it's really nice to model things in F#. But the constructs that we use are relatively simple. You know, we've got a simple record, which is, you know, it's a name and a date of birth and a place that you live, or it's an all type, so it's a discriminated union. I don't know, would you like an apple, an orange, or a banana? And we build complex types up from those simple structures.
Yeah. I actually have on screen, you cannot see this, but you posted on LinkedIn an example of modeling a menu.
All right, yes. Yeah, there's a couple of holes in that at the moment, but it's a very early stage version, but it's quite readable, I think.
It's very readable, and I think it's a good, even if you don't know F#, it kind of shows what you can do, which is really cool. I'm particularly, so I like this. You have type doneness, which I guess that's a union type, right? Extract,
yes.
Rare.
Yeah, so it's called a discriminated union F#, but it's a tagged union in most functional languages. Yeah, so it's one of those.
Yeah. I like the syntax, by the way. This is one thing that I'm very envious on, this type of syntax where you have the slashes, the bars.
Yeah.
And then, menu item detail, which is, I guess, a record of some type, and menu item.
Yeah, so it's F sharp, like most functional languages, is all about composition. Yeah, it's composition of types and composition of functions. It's taking small things to make bigger, more useful things.
Yeah. So with this example, it's really cool. And I'm just noticing now you have in the time menu item meat of details, which is a composition between menu item details and doneness.
Yep.
And
which obviously doesn't work for things like chicken and fish. But yeah, it was an early stage, just an idea of just trying things out, and then we'll extend it from there. Once you find the edge cases, you then look to say how do we solve the edge case. Yeah. So the other one that's sort of missing as well is it's possible to order nothing.
Yeah.
So there are 3 options for starter, main, and dessert, and if you order nothing for each one, then you've not ordered anything. So
yeah. So you need to, of course, cover more. But it's just, in terms of syntax, it just looks nice.
Yeah, but this is the type system. So the type system is giving us checking, if you like. It's trying to make sure that you can't have invalid states, that you're only allowed to do certain things. It's obviously completely against the dynamic style that you're sort of pushing with Python, which takes a very different attitude, which you gain flexibility in other areas, but you lose control with having a type system.
Yeah, so actually this type of, what I'm seeing here is quite nice. And I'd like this style of type system. Where I think it gets a bit weird is when I want to write functions that are generic to different types, and I don't care about the types that go in there, just about what the function is doing, more or less. Which sometimes makes sense, sometimes it doesn't. Sometimes you need very concrete functions. But every now in a while you get some things that kind of apply to more. And I don't really care about specifying. So there are a few things that I don't like doing with type systems. One of them is doing casts. I think casting is weird. Checking whether something is of a specific type.
Yep.
And having to specify types on every possible function, variable, and so on. I want to specify on certain functions, on certain variables, but not on all of them.
Yep. So F sharp takes a midway view on this. So F sharp, the compiler can infer types by how it's used because when you write F sharp code, the compiler works from the top of the page downwards, a bit like JavaScript, and the same in files. So when you add files to a project, it works from the first file, loads everything in, and then you get to the final bit and it runs that. So it can use type inference. So you don't have to set the types explicitly. Also, if the compiler can look at your function and say, well, actually, that's a generic function. So things like equals. If you put two things into an equals function of the same type, that's generic because the compiler can infer that it could put anything into this, and all it's doing is comparing one to the other and returning a Boolean of true or false. So it will actually do that for you. And same with something like swap. You've got two values, swap them round. Again, it can infer that that's generic. So you sort of get the best of both worlds. So if you want to put types on things, you can put type abbreviations on every single or whichever of the parameters you want to put them onto, and the same for the return type as well. But also when you're looking at the code in the IDE, what the compiler does is it actually tells you what the signatures are of each of the functions. So what I tend to do is on my public functions, I'll often put explicit types on those, and then all the functions inside that I don't need to, because as long as it compiles, then I know that they're the right types anyway.
Do you ever get really weird errors?
Oh, yes. Yeah, but the weird errors are generally my fault rather than the compiler's problem. It's because you get little things like because you get flexibility, you get things like partial application. It's very easy to forget that you haven't applied all of the parameters, and it's still valid. All you get is a function out of it, and you try to pass a function into something that wasn't expecting a function, and you'll get errors. But then it's very easy to work out where the problem is, because the compiler will tell you that this isn't what it was expecting. And when you look at the signature, it's trying to work out what you're trying to do, and it's trying to put a type signature on it for you. Sometimes it can't do it. Sometimes it will put something really odd, and you'll just think, well, that just looks completely wrong. You work your way backwards one function, and you realise, well, I didn't fully apply all the parameters. So that fixes that. So yes, you do get them occasionally. But the F# compiler is really good at helping you with that. It will generally tell you that this is where the problem is, and then you go and fix it, and it all works. Sounds magical. It sounds it sounds absolute. But actually, I mean, obviously the compiler is written by much cleverer people than me. It works really well. It's tried and tested. It's been around for a long time, and you learn very, very quickly to trust the compiler. To not have to, if the compiler says you need to do something, do it, and it will work.
Cool. Well, that's good to hear. I believe this can exist, but I think many other languages have took a wrong turn. And I'm thinking, so I have a story about Haskell, for example. I have a friend, and we were meeting from time to time as part of a small group of software developers in various cities in Europe, and that happened before the pandemic. And at one point we met, I think we were in Belgium, and I sat down with a friend who does Haskell, and I said, okay, so let's try to write a web application. And first of all, he was really shocked that I suggested something like that for Haskell. Then we looked for a framework, and I don't remember exactly which one we picked, but we picked one of the, let's say, more famous ones, or more, the first on Google. And it took us about half an hour to just figure out how to start.
Wow.
Because the names were so weird. Everything was very abstract. And I was with an expert in Haskell. If I were to do this by myself, probably it would take me a few days to just figure things out. And that was when I first realized, look, I think there's a blind spot for some of these type system proponents, which is that they forget about names. They forget about naming things properly. And then because you don't have proper names, then you don't get clear error messages and so on. So, but it's good to hear that with F# it's different.
Yeah, I mean, some F# code I've seen written is very impenetrable. There's nothing to stop you calling things A, B, C, D, functions F and things like that. It's not everybody does everything properly. But there's no reason to stop you writing good code in any language, to be honest. It's just taking a little bit of time and thinking about it. I think that's one of the problems that I have with a lot of code that I see is a lot of the time it's very hard to work out what the code actually does. If you don't name things properly, it's very hard. I find a lot of C# code very difficult to read now because it's so noisy. There's so many, particularly if it's not written in a more functional style, and I'm trying to work out where the mutability is happening and what's happening in a loop and all the rest of it. And I just find that too hard to read now. Whereas a functional programming language, just being able to write small functions and compose them together, I find that much easier to reason about. But I've always been like that. I can't say I've ever been able to hold big programs in my head like some people can and step through and work out and remember where they are and where they need to get to. I just can't do that.
I'm the same, actually. I've been looking I think maybe in the beginning of my career, I was able to look at larger pieces of code that I wrote and kind of remember what things are.
But not 3 months later when you looked
But
at
not
it again.
months later, yeah. And even today, probably if I am writing a piece of code that's slightly more complex, I think I will be able to remember it. But I still wouldn't trust that it works perfectly. I know I'm making mistakes. I know I will be doing something wrong and missing some cases or so on. So this is why I prefer to kind of build things little by little.
Yeah.
And that's actually where I come from with these type systems, because one thing that I know that we are talking now about a domain model. So if you start with a domain model and you kind of build it from there, it's okay. But if I don't start with a domain model and I kind of build it incrementally, I need this flexibility in type systems.
Yeah. Yeah. So one of the nice things that I found with functional programming is that I concentrate on, I was going to say behavior, but it's not behavior, functionality. I concentrate on the verbs in the domain rather than the nouns. So I don't spend lots of time thinking about, well, I need a user, I need a room class, and I need to have these properties on it, and then I think about what it actually does. So I tend to think more in terms of what does this system need to do, and I think about what data do I need to provide to that function to do that thing, and what do I want to get out of it at the end of it. And that makes life much easier to, these things much easier to reason about. And then I can work backwards and build. If I need to build nouns, I can. But often all I'm building is data structures.
That makes
because I've got standalone functions.
So how have you used the domain-driven design? Is it complementary to functional programming? Is it?
Yes. Yes. So obviously when I started looking at domain-driven design, I bought the book I think in 2006. So Eric Evans' Blue Book. I read the first 2/3, as everybody does. I learned all about entities, aggregates, value types, all the rest of it, and then got to the end bit, and I thought, oh, that's not really that interesting, and put it down. And then I read it a couple of years later, and I'd been told that I'd actually read it incorrectly. I should have started on the last third, read that, and then gone from the start all the way through. So you read the strategic stuff first, then you read the tactical, back onto strategic. It's one of those books where every time you read it, there's more and more meaning comes out of it. So as your experience grows, you start to understand some of the things that Eric Evans was trying to say. It's a very wordy book. It's a very dense book in terms of ideas and then things that he's trying to get across. So you never get it first time anyway. So what I've tended to do with obviously being split into two parts, strategic and tactical, I've concentrated on the strategic side. I don't really look at the tactical side, particularly from a functional programming perspective, because things like aggregates don't really make that much sense. It's still partly true, but it's less important. But for me, the most important part is the strategic side. So thinking about your bounded context, thinking about how your bounded contexts connect together, so the context map, and also the vocabulary side, so the ubiquitous language. So that side is the more important side to me. As the systems gets bigger, it's more important to get that correct than it is further down the line. And it's almost as though the programming language that you use doesn't really matter. It's more important to get how you split the application up correct first, and then pretty much any modern programming language will work for most of the code that you write.
Right, and I see that you've used CQRS as one type of architecture.
Yeah, I mean, I wouldn't really call it an architecture. It's more I know some people do. It's more a logical splitting of reads and writes. It's an acceptance that when you read something, you want to just get it out as quickly as possible. When you write things in, you've obviously got other work to do, like validation, parsing, various other things as well, and obviously writing to a data store. So I was quite lucky with CQRS and event sourcing, because I was sort of attending things in the alt.NET community back in the late 2010s, late 2000s rather, so probably 2008, 2009. And Greg Young came over to the UK and did a little workshop. And there were 6 of us in this workshop in the back of a Costa Coffee at Liverpool Street Station. And Greg Young actually went through CQRS and event sourcing with us over the course of about 4 hours. It wasn't even called CQRS then, it was called Distributed Domain Driven Design. So 4Ds. And then it quickly became CQRS once other people get involved as well. So yeah, it was one of those things, it's so obvious that you think, why didn't other people think of this? You know, it's because they are different things. But then then there was the other side, which is the event sourcing, which is just looking. I mean, it's been around for a very long time. That's how databases used to be back in the days before SQL databases came out. They were basically ledgers. So yeah, I was very lucky to pick that up, and I've sort of dipped in and out of it over time. It's not something that I do all the time. It's things that I do occasionally. I don't think it's one of those things that you can. How do I put this? So there are some people who think that you should do everything in event sourcing and store the events, and there are other people who think it's the worst thing ever and you should never do it. So I'm sort of very much more towards the it's a really good idea side of things. So the big thing for me for event sourcing is what you get out of it at the other end. You know, if you just store state, all you can see is what the current state is. You end up having to write extra things to record what's changed. So with event sourcing, what you're doing is recording every change that happens. But then you can say, well, how do I view the data? Well, you generate projections, you generate views from that data. And if you want to, you can regenerate them at any point. So it's really good. So what's really good from that is you can answer questions you didn't think you wanted to know. So you've got recorded data from whenever the start of the system is, and you can then generate a view based on a question that you hadn't really thought that you were going to ask. Obviously, it depends on collecting enough data to do that, but there's a good chance you've collected it anyway. So one of Greg's examples for this was things like a shopping cart. So normally all you do is record the items that actually got ordered or bought. But what happens about the items that were added and taken out? Does that tell you something? You know, is there any information that you can glean from that? Maybe, maybe not. I don't know. But sometimes that information is useful. So yeah, I was lucky to get in. I was very lucky to get involved in that. So it's something that I have been dipping in and out of all the time, keeping an eye on.
Yeah, I'm actually curious about practical applications. So I know you probably have some restrictions on what you can tell stories about and what not, but it would be interesting to hear about your experience with a project or a product where event sourcing or domain-driven design has actually been very important, or you found it as being very important.
Well, virtually every project I've worked on in the last 10 years, it's been important because the size of the project is growing. You know, trying to work out what type of project to deliver. So I've done quite a lot of things like event storming. So that was quite a useful thing. So I worked on a project for the Skills Funding Agency in the UK, which was to do with the apprenticeship levy. which is trying to get companies to pay into a levy to train apprentices, to train them to learn new skills. And that was a government policy quite a few years ago. And I was involved in the starting of that. So I worked on the initial versions of that. And that was quite interesting, getting people into a room and talking about what happens. So what interesting things happen in the domain. So when somebody registers, that's an event that you're interested in. So you look at it from both sides. You look at what happens when that event happens and what causes that event to happen. And you look at what the problems are and how that impacts the system. And having quite a few people in the room looking at this on a timeline, trying to work out where the problems are, it was a really interesting project. It sounded really simple when we started it. And then when you got into the nitty-gritty, the details of it, actually, some of these things started off really small and just exploded. Same with so the last project I worked on was for a company doing GPS aggregation. So again, sounds really simple. You get the data from some GPS provider, get it into your system, and somebody can have a look at it. Sounds really simple. Getting the data was really interesting. Again, it's exactly the same. It's working out what the system needs to do. So it's breaking down what not just what it needs to do, but what it could do as well. So we started off. Our initial requirement was to collect data from various GPS providers, bring them into our system, and push them forwards to another system who would work out the estimated time of arrival. So this is trucks delivering stuff from one place to another across Europe. So they're quite long journeys. They have to make sure that they get in at their specified time. If they're not, they need to rebook the slot. So it's quite important to get right. So we built this. We started adding more and more providers on. So we were interfacing with 300 or so providers in the end. But then they realised that actually we could do far more with this. We could provide APIs. So people could use our system. We could use it as a software as a service. So people could actually send data to us, go through our aggregation system, use our ETA system. Or they could, we could collect their data from the providers, go through our system, and we could send it via an API to them. And it's been pre-aggregated. So we actually provided more features by talking to the customers and working out what they wanted.
I mean, that's one of the approaches that I like, is actually discovery together with the customer, figuring out what you can do more than what they expect.
Yeah, I think my favourite ever event storming session was I did one session and it felt really uncomfortable because it was basically, this is how the system works, this is how the system works, this is how the system works. And we did this thing and it had all sorts of red flags on it and various other things. And I went back the next day and I said, right, if this system didn't exist, what would you want it to do? So we actually went through and there were a couple of problem areas and actually we came up with a better solution. And when we got into the software, we found that we could actually replace large parts of the software with this new process. But it was only through being dissatisfied with what we'd done the previous day that we actually sat down and went through this new idea, of what was possible. And it was a really interesting session. I find event storming quite refreshing. It's a great way of me learning the domain. So they start using words and I start asking, what does that mean? Which is quite interesting, because if you've got people from different departments, one will tell you that it means this and the other will tell you something completely different. But again, that's great for bounded context and ubiquitous language. So you're learning stuff all the time. So we're building up a dictionary of words and meanings and looking at where they belong. So yeah, for knowledge transfer, it's a fantastic way learning about how a system works or how a domain works.
Yeah, and also for separating, I guess you're using it also an input for architecture, right? Afterwards, like how you structure your modules, or
Yes and no. So bounded context doesn't correlate exactly to deployables. So it could be that you end up splitting a bounded context into multiple deployables, but they're all the same, all deployed at the same time. But so we certainly had that with the GPS system. There was one of the bounded contexts was just too big. There were 3 deployables within one bounded context, but that worked really well. So it's not quite as simple as you get your bounded context, you create a project, you deploy it, and everything's perfect. It's not quite as simple as that. But you have.
It's an input. It's not the solution.
Yeah, absolutely. Yeah, I mean, you have to think about. There are obvious things to think about. So you've obviously got to think about how many users you've got on the system, how much data is going to travel through the system, which parts of the system need to scale. One of my problems with a lot of, certainly the older systems, was one architecture for everything. So you spent a lot of time on areas that weren't really that important. You spend as much time on those, if not more time, than the areas that were vital to the system. So the core areas. So it was... So yeah, it's been nice to actually not break it down to microservices. I'm still not convinced on the microservices idea of things. It just seems too much like hard work, splitting it into a little bit. It seems to work for lots of people, but I still have problems with it. I look at it still in terms of services. So having something a bit bigger rather than lots of small things. So you've got bits of your system that are probably more important than others, but yes, you do need to look at things like scale. So there are parts of a system that lots of people will use, but they won't use it that often. So it probably doesn't need to scale that much. You probably, for instance, have a website with potentially multiple instances that could run. Whereas you've got other parts of a system where lots of data gets pushed to it. So you need something that scales very quickly, that might have 20 different instances running at any particular point in time. So those sorts of things I find quite interesting. I worked for a clothing retailer in the UK, a big online clothing retailer, and they had 2 massive sales every year. But they knew when the sales were, and they built their system in such a way that they could scale just before the sale happened and turn it down after the sale had finished. So they could just tick along at quite a nice rate for the rest of the year, and then they could scale the bits of the system they needed to for when the sales happened.
Yeah, I mean, that makes sense. And I think I talked to we actually have courses for software architects, some of them for beginner software architects, or for developers, from developer to architect kind of thing. And one of their surprises is we talk about scaling, and they're like, yeah, but it's, the cloud does it. It's like, yeah, but it's not free. You need to take this into account because it will cost money. So maybe it's able, if you're using AWS or Microsoft Azure, it will start for you hundreds of instances, but you need to pay for those. So it's up to you.
I mean, this is one of the reasons why things like Cloud Functions seem to be quite popular, because they only charge you for when you actually use them, and they're generally sat there doing nothing. So when they're deployed, it doesn't cost you anything, but it costs you money every time they're called. That's quite an efficient way of doing it. But certainly having the ability to know that for a particular 3 or 4 day period, you're going to be extremely busy, and all you do is just turn the numbers up a little bit. That does make life much easier. But I'm still not convinced on the cloud. I'm the same as you. I think there's a lot of waste going on in the cloud. There's a lot of what happens if this happens? So they bump the numbers up. They make all the VMs very large. They have more instances than they probably need. It also doesn't make them think about how to efficiently write programs either. If you know that all you've got to do is just turn it up from 4 to 5, what's the incentive in writing a more efficient program?
Yeah, trust me, there's a good incentive when you see the bill for maybe in the first month it doesn't hit you, but afterwards it starts to hit you. Yeah, I've been using the cloud. I don't have anything, mostly AWS.
I've not used AWS. I've used Azure and Google Cloud, but not AWS.
Yeah, but mostly for one thing that you need to be wary of, I think, whenever you are using these types of technologies is to understand that there's also an illusion there. There's the illusion that there's no machine. There's the illusion that it will just spin up more machines for you if you need to, and so on. And because of that, maybe you don't think about performance, maybe you don't think about scaling, maybe you don't think about security sometimes, because that was another question that I often had with architects, beginner architects, is like, yeah, but AWS will do the security. No, it won't do the security. It will do parts of the security, but you still need to figure out how to encrypt data between services and which are the authentication zones and all those things.
Yep.
It's not magic. You still have to do your job as an architect.
Yeah.
So I think that's the most.
Yeah, the hardest problem with the cloud for me is telemetry, finding out what's going on. You just said that nobody really knows what the performance is like. So things like, how long does it take a message to get from point A to point C? So how quickly are you processing things through the system? We had queues at various points in the last GPS system I worked on. And obviously queues are not instantaneous. They are most of the time. But sometimes they're not. Sometimes there are delays. If you get lots of messages sent, messages can sit there for a few seconds before they're processed. So it does take a little bit of time. So it's nice to have information. So we would obviously collecting hundreds of thousands of data points from vehicles. We're collecting 10 million signals a day at one point. But somebody would ask about a particular registration number. And we'd have to then go through the logs and have a look at what data we'd received. So we ended up writing a UI that collected all the data, and we could query the data on that. But yes, it was a big learning experience for us. We didn't look at telemetry for the first year, and we'd had a system running for probably 6 months of that time. But it wasn't a major problem for us. We were lucky in some ways in that because of the nature of the domain, we were collecting data every 10 minutes for each vehicle. That was actually more, the data was appearing more quickly than the people who were looking at the data and using it could deal with. So the person who's actually using the data is probably only ever going to look 3 or 4 times in a journey. But we were collecting every 10 minutes where these vehicles were, and they were doing the ETA calculations. So it didn't actually matter if we lost signals, because in 10 minutes' time there'd be another signal coming down.
Yeah.
So we're quite lucky in that perspective. It wasn't like a bank where you have to make sure that every single message is accounted for.
I know that on the marketing side, AWS they have pushed about a project related to Formula One.
All right. Okay.
Quite similar.
Yep.
So collecting telemetry from Formula One cars and processing it and so on. But on the other hand, this is the marketing side. On the other hand, I also know people who have been having troubles with this type of data that you're talking about, and actually found bugs in AWS that they had to fix because some of the things were not visible or unclear, or they were missing some logs and so on. It was virtually impossible to debug, let's say, so small things. It's like any platform, right? You're giving something away, you're taking something. But don't expect it to work by magic.
Well, yes. I mean, it's one of those things, isn't it? It's like all software development. It's all, some of it's good, some of it's bad, and it's working out whether it's more good than bad for you. So having the stuff in the cloud means you don't have to have somebody locally provisioning. It's installing updates and things happens automatically or relatively automatically. So there are benefits from that, but it's a lot bigger cost over time.
So talking about things that are good, let's go a bit back to F#, because you also wrote a book about F#, which is essential.
I did 197 pages of joy.
Almost 200 pages.
Almost 200 pages. 197. Yeah.
First question is, how did you think about writing a book?
I didn't. So I originally wrote a series of blog posts. So I obviously I joined a small team, and we spent time sort of making sure we'd get up to speed with F#. So there were only 3 of us, and as we were adding people, it came to, well, how do we train them in F#? It means I've got to take time off and teach them how to do it. So why don't we look at what we actually use for our product, and I'll write a series of blog posts, and they can read the blog posts, and if they've got questions, they come back to me. And I ended up writing, I think I wrote 12 or 13 blog posts. And once I got maybe 9 of them done, I thought, actually, this has more applications outside here than it does just a set of blog posts. Why don't I make a book? How hard can it be? So yeah, I took those chapters as the basic building blocks for each chapter, and then looked at the things that I think that I could improve. Looked at extra examples of how to do it. Added a few extra pieces in there. Put it out to the community and said, does anybody want to review this, have a look at it, and help me make the language better, help me make it, because obviously as the writer of the book, I'm making assumptions about what people know and what they don't know, and a lot of these were unconscious. So I'd write things and not think about the fact that they actually need to know a couple of other things as well. So getting things in order was quite interesting. So the feedback was fantastic. I'd get. It wasn't just typos, but it was obviously checking the code samples worked, making sure that the language actually made sense. There were people from across Europe. In fact, there were people from across the world who reviewed it. So it was nice to get feedback there and say, well, I didn't understand this phrasing. How do we change it? So I'd edit it, change it, put the version back out again, and people would come back and say, that's much better. So I ended up with a much better book at the end of it than I would have done if I'd just done it myself. So yes, it wasn't intended to be a book, but it just ended up becoming a book. And I think it's quite good, to be honest. I don't think it's blown my own trumpet a little bit here. But it's short. It does exactly what it says on the cover. It's essential F#. It's what you need to know if you're writing a line of business app in F#. There are a few holes in it. It doesn't cover talking to a database or JSON, but they're things that you can learn from the internet. There are plenty of other sites out there doing it. Takes a different approach to the problem than, say, Isaac Abraham's book does. So F# in action, that's very much more that covers a lot more of the basics than mine does. Mine assumes that you know .NET already, for instance.
I actually like the introduction. I just got it yesterday and took a look, browsed through it, and it was quite interesting. But in the introduction, you say, Although F# has often been portrayed as a functional programming language, it isn't, and neither is this book purely about functional programming. You are not going to learn about category theory, lambda calculus, or even monads. You will learn things about programming in a functional first style as a byproduct of how we solve problems with F#. What you will learn is how F# functional first approach to programming empowers everyone to write succinct, robust, and performant code. And I really like that approach. So I'm not sure if you know, but I actually published a book on functional programming in C++.
I didn't know.
And one of the funny things there is I really wanted, this was with an editor, so they asked me to publish it. And I really wanted to write for a very long time about monads, but without saying they are monads. Kind of building up to them. And there is actually one chapter in the book that's innocuously called, I think, functional design patterns or something like that, but it talks about it.
Okay.
So, why did you choose not to talk? That's just out of, I understand perfectly why you wouldn't touch category theory or lambda calculus. Are monads used in F#? Or?
They are, They are, yes. They're not called monads, but they are used. I chose not to do it because it's a lot of the reason that people don't like functional languages is because it sounds scary. They think that you have to have a degree in mathematics. It doesn't help the fact that I have a degree in mathematics because it doesn't really help my argument. But so be it. It's, you don't actually need to know any high-level mathematics. You don't even need to know any simple mathematics. It's really it's not about that at all, and that's what I'm trying to get across. It's more about it's great for writing line of business apps. Doesn't mean that I can't describe what a monad is. It's not. I actually saw a video a few days ago from a I'm assuming he's French. I've forgotten his name now, but he'll come back to me. But he explained monads in a really simple way, and it was it's a way that I've not heard it. I normally do it in terms of a concrete example.
Yeah.
But he did it in a much more general way. So his idea was, so if you take two functions, you've got one function that takes, I'm paraphrasing a little bit here, but you take a function that takes an apple and returns a banana, and you have another function that takes a banana as input and returns an orange. So to compose them together, that's really simple because the output of the first function matches the input of the second function. So what happens if, for the first function, I decide to put that banana in a box, and that box is an effect. So it could be I/O, it could be exceptions, options, anything like that. It's just a general something. So you now have a function that goes from an apple to a banana in a box, and you've got a function that takes a banana and returns an orange. So how do you get that to work? So you need to come up with a function that will take the banana out of the box so that you can then run the function that takes the banana and returns the orange, but then it needs to put the orange back into the same type of box for the output, because you need to pass that type down the line. And that function is called BAP, and that's a functor. So that's part one. So the next part is, right, I've got this function that goes apple to banana in a box, and I take the second function and I make that a banana to an orange in a box. So I've got the same effects on both of them. So how do I do this? Well, I've already got something that might work. So I've got this map thing. So I can take the banana out of the box. I can then run the function that takes a banana and returns an orange in a box. But then I need to put another box in it because that's what the map function does. So I've got a box containing an orange. So what I need to do is I need to take that outer box away, and that's called flatten. So you do a map and a flatten. And because it's such a common thing, that's called flat map. And flat map is a monad.
Yeah. Yeah.
So that's it. So in a minute, he's described what a functor is and what a monad is, and it's a really simple idea. So it's a way of dealing with functions that return things wrapped in effects, wrapped in something else. So dealing with things like I/O exceptions and all those sorts of things, and still being able to compose them together. I just thought, but he used colours rather than apples and bananas. I just thought banana in a box sounds more reasonable.
Yeah, I guess the problem for many people who are used with object-oriented, or what I actually call class-oriented design, because it's mostly we write classes and it's not really about objects, is that first of all, they realize that this concept of functions is so powerful, and you can do all these kind of functional operations like partial application and composition, and then that you can take them to the next level and kind of have functions that receive functions and other things and so on. And when you also combine these two, it's already mind-blowing. It requires a lot of mental effort to figure it out, which is I really like this constructive way of explaining it, starting from we need this, let's see how you do it. We need the next thing, let's see how we do it. It's much easier. Yeah.
And that's what I try to do through the book. The book is really trying to explain things in a very sensible way. I don't look at things in terms of this is an idea. Sorry, this is a feature, and then we think about how you use it. I tend to think more in other terms, which is, what do I want to solve, and what can I use in F# to solve that problem? And that seems to work quite well. So it's all practical. There's lots of code in there to work through.
And to come back with to my example with Haskell, I really like that you have a chapter on writing web applications.
Yes. Yeah, I mean it's a really Giraffe, which is what I use in the book, is a really nice thing. All it is a very simple wrapper around ASP.NET Core. .NET, or .NET Core in particular, is really good. ASP.NET Core is a great platform to build web applications on. It's I think back at some of the things that I've worked on over time using things like web forms. Web forms wasn't for the web. Web forms was an intranet thing for building internal systems rather than dealing with the web. So I've looked enviously at lots of the web platforms and frameworks on other platforms. The Python ones look really good. Flask, is it one of them? Yeah. So they're very web centric. They're very simple to use, and they work really well. But what we've had in the .NET world has been always quite heavyweight. So even MVC, it was a big improvement over web forms, but it was still, you opened an MVC app up, and it was an MVC app. You actually had to delve inside it to work out what the app actually did. Whereas you look at most of the other frameworks, and what they do is you can immediately see that you're building a to-do app or you're building a sales app, and that's obvious from opening it up. But you couldn't see that from MVC. I like functional programming for the web because basically the web is stateless. So it's functional programming. It's if you think about the web request, you send a request in and you get a response out. But actually that response is an asynchronous response, and it could return nothing. So actually it's an asynchronous option of a response. But that's a function.
Yeah, it's actually very easy to model and to separate command and queries, as we were discussing before. And then your queries, these are actually the only things, or how would you say, you can have things in the center that are pure functions, and just at the edge have things that talk to the database or whatever you need to. It's very easy to do that, and it makes things much, much easier when you develop software like this.
It does. Have you read Grokking Simplicity by Eric Normand?
No. I missed
So,
it.
so that's worth reading. So he basically talked to lots of functional programmers and distilled lots of their ideas, and he came up with basically it's three things. So you've got calculations, which are pure functions, you've got actions, which are impure functions, and you've got data.
Yeah.
And that's it. So you've got three things in functional programming.
Yeah. And particularly when you can do data types that are smart and easy to do and easy to combine and
Yep.
kind of compose, it's quite good. So I think we could go on for a few hours, but I propose that we go to what we usually do in the end of these interviews, and I'm gonna ask you 6 questions.
Okay.
And the first one, what book did you like and would recommend?
Oh, that's a tough one. So on my blog, I've got a top 10 of books that I really like. There are 3 that really stand out for me. So Extreme Programming Explained is one of them. The Domain-Driven Design book, so Tackling Complexity at the Heart of Software. And finally, Domain Modeling Made Functional by Scott Voloshin as well. So those 3.
Right.
So the basic idea of domain modeling is it just basically explains it really well.
Cool. Second question, what category of books you don't read too much and why?
Most of my books tend to be technical. I used to read a lot of science fiction, but I don't really read that much anymore. Or they're political. Sadly, yeah, I'm really sad. I don't really read things like love stories and that sort of thing. It's not really me. But as long as it's a well-written book, I'll read it. I read biographies and things as well. So,
right. So
yeah, I can't say I'm anti anything. But you know, if it's well written and people say you should read that, then I'll often read it.
What topic do you think is not discussed enough in the industry or our communities, software development communities?
I still don't think software quality is discussed enough. So a few years ago I'd have said communication, but I think that's being pushed by everybody now. All the soft skills is being pushed by everybody. And I think there's virtually nothing now on software quality, on writing good code. Right. Although certainly in the .NET community that seems to be the case anyway. It's more about the features than actually putting them together properly.
Yeah, it's a solved problem.
Yeah, but it's
the solved problem, but it's not, because you still need the practice actually.
Yeah. Yes, I mean that's one of my issues with object-oriented programming. You can write fantastic programs with object-oriented programming, but you have to be really good at it. Whereas functional programming is much easier to learn, much easier to reason about. You don't have to be so good.
Well, that's an interesting point of view, because usually, I guess most people who come from learning structured programming first, things like C and imperative style, they find it very difficult to switch to functional programming. And actually that has been my story as well. I started programming quite early with BASIC and Pascal and then C and so on. And when I first saw functional programming, I was in university and I couldn't understand a thing of what they wanted from me. So there's also the other side. But my assumption is that it depends a lot with what you start. If you start with functional programming, that it all makes sense. If you start with imperative, it's very difficult to switch.
Yes, I think it's one of those. If you took 2 groups who'd never programmed before, the ones who learn functional programming would be up and running faster than the ones who learn object-oriented programming. But going the opposite way, the hardest part is unlearning what you already know.
Yeah. Yeah.
You know, because you think in terms of objects, you don't think in terms of functions.
Right. Yeah, makes sense. Question number 4. What topic do you think is discussed too much in the industry or our communities?
That's a hard one. New features. When somebody comes up with a new feature, you know, if there's a new release of .NET, everybody blogs about it. You know, it just seems, you know, it's almost like saturation, which is great from one perspective because you get different points of view, but it's often these new features are fairly small and everybody's writing exactly the same thing and how wonderful it is and all the rest of it. Not all new things are actually progress.
Yeah, exactly.
So I wonder about some of the new stuff that's going into C#. It's very, whilst from a functional programming perspective, I really like it, it's actually very different than what they've had before in terms of object-oriented programming. You know, we were talking earlier about not liking casting, for instance. Well, that's effectively what you're doing with things like pattern matching. You're effectively casting things into a type and then working with that type rather than using an interface and working against an interface rather than a concrete type with different capabilities.
This was actually one of my gripes with the Microsoft ecosystem. There was too much marketing for my taste back when I was still doing Microsoft stuff. And oftentimes it was, there's the new version of .NET and it brings so and so. And I was like, yeah, but how does this help me? You know, some of the things were good, some not so much.
Yeah, but when they put new features in, often they're to solve a problem that other people have raised. But a lot of the time now, the new features that are going in are Me Too features. You know, Kotlin's been really good for the JVM because it's introduced people to a new way of programming, and it's a nice language to work with. And obviously, the C# people are looking at that and thinking, well, we need to have all these features that's now got. The same with Python as well. Python's got lots of really nice functional stuff in it, you know, and they're trying to keep step with these other languages, and sometimes they're just not appropriate.
Yeah,
you know, the new features are not appropriate.
Question number 5: what would be your ultimate career achievement? So something that if you do, you think I can now retire. Not that you have the money to retire, but to think like I'm done.
Well, I've still got 10 years left of software development. I still enjoy writing software. I still like being involved in the whole process. I've achieved something I didn't think I'd ever do, which is writing a book. You know, that's something I never ever thought that I would do. I've never really looked at it that way. I tend to look at it in terms of I'm never going to be an MVP because I'm too outspoken. I don't agree with lots of the marketing side of things, so that's never going to happen. I'd like to be seen. I'd like to feel that I'm an expert in something. You know, and I don't feel like I'm at that level. I might be an expert in terms of explaining functional programming to new developers or developers new to F#, but it's nice to sort of have people say, yeah, he's a good developer. Yeah, and I don't feel like for some reason, I don't feel like I've ever reached that sort of level. Whether that's true or not, immaterial. It's how I feel inside about that.
Yeah, I think, well, many people who were experts, they were actually very unhappy with themselves all the time. So I guess it comes with the territory.
Yeah.
Because you just want to learn more and more. You feel like there's always something else that you can know, that you can do better, and so on.
Well, there is. I mean, it's I don't remember who said it, but something along the lines of the more I learn, the more I realise how little I know.
Yeah, absolutely.
You know, this field that we're in is just so big and growing all the time. You can't be an expert in everything. You know, the best you can hope to be is good at certain things.
Yeah, absolutely. All right. And question number 6. What advice would you give to a younger version of yourself?
So if I started again in 95, what would I say? I'd say find a mentor. So in every company you're in, find somebody who can teach you how to do things the right way. So I didn't learn that way, and I think it's taken me a long time to get to the point that I've had to do a lot of self-learning. You know, a lot of trying to filter out the good from the bad. So that was one of the reasons for going along to things like Socrates and meeting folks like you. You know, it's being able to talk to you and then have discussions with people about various topics. It's good feedback. It's good to know that your thinking is along the same sorts of lines. You know, it's good reinforcement, if you like. It's also good to know to build up your list of friends, your list of people that you know that you can go to for advice. So if you get stuck on a question, you know that, well, they might know it, or if they don't know it, they know people who would know it. Yeah. So yeah, get a mentor would be number one. If I had to do something else, it would be there might be 24 hours in a day, but you don't have to code for 24 hours a day. Use your time wisely.
Absolutely.
You know, life's about more than writing software.
Yeah, and I think, I mean, hearing what we discussed today, I think many young programmers would be very lucky to have you as a mentor. So,
thank you. I enjoy it. I do. I normally have 2 or 3 people for a 3-month period doing F#. Cool. So I'm doing that for free. I've been doing that for about 3 years now. I found that very fulfilling. Obviously, it depends on how much effort the mentee puts in from their side, but most have been really good. Most have put in an extra bit of effort every time, and it's great to see them come out at the other end. Most of them have carried on doing F# one way or another. You know, so that's really good from my perspective. I wish that I could clone myself a little bit to a certain extent, because then I could offer it to more people. So I've looked at things like videos, and I just find them really uncomfortable. You know, you're obviously used to this. You're on show 100 and something or other, so you're used to being on that end of a video camera, and you know, it's quite easy, but it's much harder on this side.
Let me tell you a secret. Actually, when we first started the YouTube channel and recording for our learning programs, because we also have our learning platform, it was extremely uncomfortable.
Yeah.
It took me about 6 months to get comfortable with the camera. And then it took me, I think, if you're looking at the first videos that we did for this channel, I was much more uncomfortable.
Yeah.
And you could see, I mean, it's almost cringe when I look back at past videos.
But that's good though, isn't it? It shows that you're learning. It shows it's like, you know, it's like looking at code that you wrote 6 months ago. You know, if you don't look at it and say, you know, I can improve this, then you haven't really improved in that 6 months.
Yeah. So,
or it's pure luck.
One thing that I've learned actually with many things, it was the same for me with public speaking. When I first started public speaking, I couldn't speak for like the first 7 minutes or so. And so what I did, I got a pair. So we would pair present. And I would start after my piece after 5 to 7 minutes. And then after doing it for a while, it just got comfortable. And
it's never got. Yeah, it's never got comfortable for me. I've always found it. I've always found it difficult. It's not. I don't know. I look at. You obviously compare yourself to other people, and I look at some of the. There are lots of. They're almost professional presenters, so they go around to conference after conference, and they speak at all these big conferences all the time. And obviously, that breeds, a level of confidence that that you can put stuff across. Obviously, they know what they're talking about as well, which helps. But I've never reached that stage. I feel very uncomfortable talking to a group of more than 10.
Well, that's absolutely fine. I mean, small groups work really well.
Well. I mean, it's not the. I mean, part of the problem is that I speak about fairly niche topics as a general rule.
Yeah. Well, also, some of the videos I did for this channel are about things that were really interesting to me, but I'm pretty serious nobody was interested on the other side. But hopefully, if at any point we'll get a video that goes viral, some of those things will get watched as well. So, it is what it is.
Yeah, it's odd though, isn't it? It's. I've used to have a blog that I use quite a lot, and the number of times that I'd go searching for the answer to a question, and I'd find the answer in my blog from 2 years ago. Sometimes it's just you don't realise how useful it's going to be to somebody until it becomes useful to somebody, and then it could be the most important thing ever. So that hour and a half that you spent doing it is well worth it.
Absolutely, yes. I agree. All right, Ian. So before we close, is there anything else that you'd like to tell our audience that we didn't talk about?
No. Try functional programming. It's not as scary as you think it is. It's once if you find a good source that will help you to learn. If you want to learn F#, there's a book out there called Essential F# you could use. But it's a great thing to learn. It's it's worth the only problem with learning things like F# is it's not good for your career because you'll end up not liking C#.
Yeah.
Sorry.
That's funny. Where can people find you?
Well, I'm on Twitter as IJ Russell. I post quite a lot on there. I post mostly F# stuff. I'm also on LinkedIn as well. I can't remember what my code is, but it's Ian Russell.
All right.
I'm sure you can add links to.
Yeah, I'll add
this talking.
In the description. All right. Well, that was it. Thank you very much. It was a very interesting.
You're welcome.
Conversation.
I enjoyed it. It's good. It's good fun. It's nice to catch up.
Yeah.
Really hopefully we'll meet up in person again at some point in the relatively near future. I'm hoping at some point to get out to the full Socrates in Germany at some point.
That would be cool. Yeah. I'm also thinking about going to some conferences as well. Yeah, and maybe, who knows, maybe we'll do some videos with F#. That might be fun.
I'll gladly do that for you. I'll teach you how to do F# if you like.
That sounds like fun, but that requires a bit more production, so we'll see how we can schedule it. But if people like it, why not? I'm all for it. All right, thank you so much. We'll just do the closing now. So, functional programming, F#, a lot of things you can learn, and I hope you got out of this conversation. Thank you kindly for the view, and remember to leave us some comments. What did you think about this conversation? Would you like to see some F# code, some F# programming? And until next time, remember to think, design, and work smart.